an ideal is when the diode is forward biased, then V forward is equal to 0. That's an ideal diode model, okay? Which means that it acts like a mechanical switch. So in a mechanical switch, when you close a switch, the voltage across it becomes 0, okay? So that's when current begins to flow. That's when we say a diode is forward biased. In a practical case, when a diode is forward biased, we say that V forward is 0.7 volts for silicon diode and 0.3 volts for a germanium diode. There are two types of diodes. Diodes are made out of two types of semiconducting material, either silicon or germanium. With the practical model, we take into account the 0.7 volts that is developed at the junction, at the PN junction. Okay, so that's the difference between ideal and practical. The complete model is the one that takes into account, include the small resistance that is present, typically 1 ohm, 2 ohms of the diode in the overall circuit, okay? So you've got the diode, there is another part of the circuit that it's controlling the current of, and so you take into account the resistance. You still have the 4.7 volts. V forward is still the 0.7 volts that you take into account. Here, the internal resistance is what's the word I'm thinking of? Is neglected. Okay? You do not take into account that internal resistance, which is a very tiny resistance. All right? So with all this in mind, let's quickly go over number 3 and number 4 one more time, which we already have. Go to page 2. Number 3. In the circuit diagram, label A for anode, K for cathode at the diode. Well, the first thing I do when I look at a diode circuit is identify the polarity of the diode. So plus minus, so as far as the diode goes, current flows from the plus of the circuit of the supply to the minus. So that's the way the current is going to flow. So therefore, what I do is identify the plus and minus at the diode. Where the current comes in is plus. Where the current comes out is minus. And what does the hint say? The hint says A of the anode. A of the anode is the arrow. K of the cathode is the vertical line. So there's my A, there's my K, and as long as the anode voltage is more positive than the cathode side, and so anode is positive, cathode is negative, therefore we say that the diode is forward biased, which means that it acts like a closed switch with a 0.7 volt drop across it if I'm using a practical model. So with the diode forward bias in this circuit, I say that the voltage at the diode is how much? 0.7 volts. Okay, as long as the voltage at the diode is greater than 0.7, then the diode is forward biased. And that's the case, because the voltage is 6 volts. I have 6 volts applied to the diode, which is more than 0.7. That will allow the diode to become forward biased, provided that the anode side is positive, the cathode side is negative. Therefore, what is the voltage at the resistor, we said? 6 minus 0.7, 5.3, and the current in the resistor. 5.3 over 1K, 1,000, 5.3 milliamps. Okay, so that's number 3. You follow the concept of how the diode works. It acts like a closed switch with a 0.7 volt drop across it. So that's number 3. Now let's do number 4. I take the same example, I reverse the diode, again 6 volts, anode, cathode, are 1K. Well, in this case, plus minus, plus minus, plus minus, right? That's how current would normally flow from the plus of the supply to the minus. So what I notice is that the anode is negative, the cathode is positive, which makes my diode reverse biased. Because anode is negative, cathode is positive, as I can see. Therefore, it acts like an open switch. And on this over here, no, let's not go there. So, open switch, voltage at the diode is therefore how much? 6 volts. Across an open switch, the voltage is the source voltage. We don't take into account that 0.7 volts. V at the resistor, therefore, is 0. Current in the resistor is 0. Make sense? So that's what we did last week. Let's go to number 5 on page 3. Any questions about the basic operation of the diode there in numbers 3 and 4? Okay, number 5. We have 2 supplies now. Let's say I've got a 9 volt supply, diode, resistor, another supply, 5 volt supply, V2, V1, R is 200 diode. So, when I have a circuit like this, where the 2 supplies are in series, what I do is I try to combine them. What I do is I move my V2 so that it appears to be right beside V1. So if I was to draw V2 right beside V1, I want to do this. Bring V2 right here. If I do that, the positive is at the top or at the bottom? At the bottom. So that's what's going to happen. If I move V2 over right beside V1, then it would be minus at the top, plus, and then plus and minus. So what happens is the voltages add up or cancel out. They will cancel. So I've got 9 volts, I've got 5 volts. It'll therefore become one equivalent voltage of 9 minus 5, which is 4 volts, with the plus at the top. So if that's what results, then with the 4 volts, then that plus minus will result in plus minus and plus minus, which means that the diode is forward biased or reverse biased. Forward biased. So, diode is forward biased because I can see that the anode side is positive, cathode side is negative, so it's forward biased, therefore V forward at the diode is 0.7. How much at the resistor? 9 minus 0.7, 8 point. Sorry, 4. Thank you. 4 minus 0.7, 3.3. Why 4? Because 9 minus 5 became 4. Okay, so that's my voltage at the resistor, and then the current in the circuit, 3.3 over 200. How much? 16.5. Okay, so that's number 5. What I did was I combined 9 with 5. The rest of the circuit is similar to the previous example. Now let's do number 6.